So hi everyone, welcome back to my channel. So in this video we will discuss first four problems of Codechef starters 104. So I was able to solve four problems, but when I go to submit the fourth problem at that time the contest was ended up. So my bad luck, I was not able to submit it within contest time. So anyways, let's start with first problem. So what the first problem wants to say, you are given two integers x and y, and there are two characters Alice and Bob as always. So first Alice starts his move. What Alice could do, Alice make the GCD of both of the numbers x and y, and he would replace one of those two numbers with their GCD, and then after that the chance of Bob's comes. Bob's What Bobs do? Bobs make LCM of those current numbers and replace one of those numbers with their LCM. So what you have to find in this problem is we have to find the minimum sum of those two numbers after k operations are applied on these two operations. So what I want to say, let's say these two numbers are x and y, and after k operations these two numbers will be x1 and y1. So what we have to make it, the sum of x1 plus y1 to be minimum. It should be minimum. Okay. So let's see how we can do it. Uh, let's see. So let us consider which test case I should make. Let's say this is my test case. 4 to 1. Okay, my test case is this. Oh, it's not pasted. I have to write it here. 4 to 1. So the value of x is 4 and the value of y is 2 and the number of operations are 1. So first what Alice will do, Alice make their GCD and replace one of those numbers with their GCD. So remember, GCD is the minimum number which will divide the maximum number which will divide both of them. So obviously the GCD of two numbers will be either the minimum of both of them or less than minimum of both of them. So it's always optimal to replace the maximum of these two elements with the GCD to make the sum minimum, because finally we have to make the sum minimum. So their GCD will be 2, and what should be the greedy approach? We should replace the maximum of these x and y's with their GCD. So after it, the number will be 2 because their GCD is 2 and we will replace 4 with 2. And now the turn of Bob comes. So Bob also have to make sure that final sum should be minimum. So what Bob could do, Bob could make the LCM of these two numbers, and Bob will also replace uh, the maximum element of these two numbers with the maximum element of these two numbers with with the LCM. So the maximum element is both numbers are same, so Bob can replace any one of them. So their LCM will also be 2 because these two numbers are same. So let's take another example in which you will understand, you will have more clarity. Let's say the value will be what should I take? Let's say it will be 3 and 9, and the value of k is not 9. Let's say not 9. Let's say 8. Let's say 8. Yeah, 8 should be the perfect choice. So the value of k is 2. So first of all, Alice will make a move. So the GCD of these two numbers will be 1. So what should be the optimal condition for Alice to replace any one of them? So is the maximum number, so Alice should replace 8 with the GCD of these two numbers. And now the chance of Bob's comes. So the LCM of these two numbers is 3, and Bob should remove the maximum element with the LCM. So it will be replaced by 3. So now one operation has been finished, and the current value of x and y is this. So we have to start from here for k equal to second move, second operation. So now the chance of Alice comes. Alice, what will do? Alice make the GCD of these two numbers. So the GCD will be 1, and what is the maximum number of these two? Obviously 3. So Alice will remove 3 with 1. Now the chance of Bob's comes. Bob will make LCM, and finally, if you notice, when the value of k is greater than equal to 2, our these two x values will be same. Why will be same? Because when the value of k will be 2, in first option Alice will replace one element with the GCD, and then finally second element. So these two values will be same when k equal to greater than equal to 2. So our answer will always be GCD of both numbers into 2 when k, the value of k is 2. So let's see the solution. This is my submission. So what I have done, I have replaced x with y if the value of x is greater than y, because I want to make sure that greater element should always be y to make the code so simple. So what I have done GCD of both numbers and replace the greatest element with GCD. It is the Alice choice, and I will check if k equal to 1. So Bob cannot do anything. Bob can do make GCD the x and y LCM. Obviously, the answer will be x plus y. You can calculate it. Otherwise, if the value of k is greater than 2, the answer will always be 2 into y, because these two values will be same when Alice applies second operation. So that's about the first problem. Let's see the solution of second problem. Uh, so yeah, what is given in this problem? You are given an array of n positive integers. You are out to do the following operations n number of times. Select two integers. Change ai to min of l and I for all I greater than l and less than r. Yeah. So it was a pretty standard problem based on prefix and suffix. So what we can do in this problem, let's say this is our, let's make our test case ourselves. It will be better. What is the input format and an array? Yeah. So let's say this is my array 3, 2, 5, 4, 7. So what we have to do, we have to choose the value of L and R. We can choose it anything, and we have to replace all elements between L and R with the minimum of any L or R. So it's always optimal to choose L equal to first number and R equal to this number. So what we have to can do in this problem, it's a pretty prefix and suffix based problem. What I will do, this is my prefix, let's say I will make a prefix of max. Let's say I will take, if I am at I position, then I will make sure at the prefix of I, the maximum element from 0 to ith position should be present at this position. So in starting I will do 3, and maximum of 3 and 2 will be 3, and maximum of 3 and 5 will be 5, and 5 and 7. This will be my prefix. And what will be my suffix? My suffix will be, my suffix will start from back. So it will be 7, and here is also 7 because 7 is greater than 4. I am comparing it from here, not this prefix. And here 7, and here 7, and here 7, because 7 is the greatest element. So in suffix 7 will always will be there always. And this is my array, and my final array should be, remember, the first and last element of my final array remain same because we can't change them, because we have to apply operations greater than L and less than R. So it's simple that we can't apply at first and last element any operations. It's very simple. So at this position, what could be the value? What could be the optimal value we should take? We can take we can take the maximum of here, or we can take the maximum of here. We have maximum of suffix at this position, we have maximum of prefix at this position. So what we can do, we can find the minimum of both of them, because we have to replace a of I with minimum, not maximum, but we have to make the sum maximum. So that's why we are taking it, these prefix and suffix, maximum prefix, maximum suffix. So what we can do, we can replace this element with minimum of p of I minus 1, or suffix of I plus 1. Or there is also one chance that if a of I is greater than both of them, minimum of them, a of I is greater than, then we should not replace that, because that will make our sum minimum. That will, okay. So let's see the solution. It will be more simple if I show you my solution. So it's pretty simple. This is my input and these are my two vectors, prefix and suffix. Prefix will, I have make this prefix, and this is my prefix, and this is my suffix, and I have reversed it because suffix should be in order way. And what I have done, I have replaced a of I with maximum of this, and I have taken minimum of prefix of I minus 1, suffix of I plus 1, and I have checked if a of I is greater than this value, then I will not make any operation on a of I. Otherwise, I will replace a of I with minimum of prefix of I minus 1 or suffix of I plus 1. So I'll take the final sum and print it. This is the problem. Easy problem. It's a easy problem, but you have to know a little bit of prefix and suffix sum knowledge. So let's see the third problem. It was also a little bit more intermediate level problem. So what you have to do in this problem, you are given a positive integer m and an array a consisting of n positive integers. Find the lexicographically largest array B such that these conditions should satisfy. So I solved this problem using the concept of mathematics. If you have read this problem, then it's good. If you have not read it, please read it carefully. There is a simple mathematical approach in this problem, which I will discuss. So what we are given an array whose values start from 1 and less than equal to m, and the value of m is also given to us, and we have to make another array which should be lexicographically largest, and all the elements in array B should lie in the range from 1 to m. And there is also one more condition, a of I is equal to GCD of B of 1 to B of I, and it is also given that input array guarantees that B always exists. Means the test case present in these problems are those test cases through which our array B can be made. So let's see the solution of this problem. So let's see the test case. What test case we should take? Okay, yeah. Let's not take test case, just solve it with mathematical approach, because it will be more clear. Let's say this is my array array A, and our array, this is our array B that we have to build up. Now the condition is A of I is equal to GCD of B of 1 to B of I. So let's solve this problem from the end side. So the value of an should be equal to GCD of this complete array. And the value of b of n should be less than equal to m, the value of m which is given to us. So please see it more carefully because it's a pretty tricky. So we have to make our array be lexicographically largest, and the value of b of n should be obviously maximum as possible because our final array should be lexicographically largest. So what we can do, we can replace b of n with the multiple of a of n, and multiple of a of n, what could be the multiple? That multiple, let's say this is my value x which is present at b of n, but this x should be less than equal to m, and one more condition it should satisfy it, x mod a of n should be equal to 0 because it should be the multiple of that number. So this is the case for b of n. Let's say I am talking about b of n minus 1, and here is the value of b of n minus 2. So these are three numbers. So I am talking about how can I replace this number. So my GCD of b of 1 to b of n minus 1 should be a of n minus 1. So do you see any correlation between it and it? This, do you see? Let's see here. So what we have to do, our GCD from B1 to Bn minus 1 should be A of n minus 1. This is our GCD. Okay. So what we can do here is, just a sec guys, I have a work to do. So yeah, we are here. So what can we do? What we have to do? We have to make the value of b of n minus 1 multiple of a of n minus 1. So let's say our value is x dash x1, which is a multiple of a of n minus 1, and it is less than m, less than equal to m. So one condition should satisfy. What condition should be that? Uh, the GCD of all these numbers b of 1 to b of n minus 1, which is b of n minus 1 is x, should be a of n minus 1. This should be the condition which should match. Guys, just a sec, one more, I have also our. So yeah, so let's see the value of a of n minus 1 to here, a of n minus 2. So what we can do here is, uh, the GCD of the value of a of n minus 2 should be GCD from b of 1 to b of n minus 2. So a of n minus 2 will represent the GCD from b of 1 to b of n minus 2. So we can use a of n minus 2 with this value from here to here. So what I can do, a of n minus 2 comma b of n minus 1 GCD should be equal to a of n minus 1. I know it's a little bit I have to make a more space, so let's see this again. So this is my array. Let's say this is my array, a1, a2, an minus 1, an, and this is my array b, b1, b2, b n minus 2, b n minus 1, and b n. So let's say what I can do, I can replace b of n with a number x which should be less than equal to m, and it should be the multiple of a of n, and it should also satisfy one more condition, that GCD from b of 1 to b of 2 to b of n minus 1 and x, the GCD of this value should be equal to a of n. And we can also say that this value is equal to a of n minus 1. Why a of n minus 1? Because a of n minus 1 will be the GCD from b of 1 to b of n minus 1. The GCD of these values is equal to a of n minus 1. So we can replace this value with a of n minus 1 and x. And our final expression is this, GCD of these two values should be equal to a of n. So I will find our value x which is less than equal to m and should be a multiple of a of n, and I will check the GCD of a of n minus 1 and x is equal to a of n. If this value is satisfied, then I will replace b of n with x value. Otherwise I will uh, replace x with x minus a of n, and I will again check this condition. If this condition satisfies, then I will replace b of n, and then I will make a while loop simply to check uh, for the final condition match. So let's see the solution. So this is my input, and if the value of n is 1, simply our answer will be the array. Otherwise this answer will represent my answer. I start from n minus 1 and go greater than 0, and I find this val is x that I was talking about here. So the value of x is m by divided by a of I, value into equal to I, which means I am making the largest multiple of a of I which is less than or equal to n. This thing I am doing, this thing is doing that work that I am talking about. And what I am doing, I make the GCD of a of n minus 1 comma l and check, and I am replacing the value of, I am decreasing the value of val uh, until these values is not satisfied, and then I will replace my val answer with val, and simply my answer of 0, a of 0 will be equal to a of 0. So this will be our final answer for this problem. Now let's see the last problem. It is a tricky problem. So what this problem wants to say, you are given a positive integer m and an array a whose value again will be from 1 to n consisting of n positive integers. Here again I have to construct an array b of length n, and again the values of array b should vary from 1 to m, and the condition here is given that for all I from 1 to n there doesn't exist an index j such that the frequency of b of j is more than a of I in the subarray. So the constraints are here 10 to the power 3. We can make our time complexity n square, and I think it will work. But I don't know, I used and I did it in an log n using sets. So let's see this problem with one more approach. With my approach, what I did here, this is my array. Let's say this is my array. Obviously, there could be some elements which will repeat. So what I am doing, I am inserting these array elements in my set. Let's say the size of this set is n1. And what can we do here? is we can make the, let's say this value is f. We can make f sets subsets f frequency of each elements f times. Let's say the value of n is 6 and number of different unique elements in it is 3. So what we can do, we can replace each element two times. We can, in our final array, we can build make two each element two times, and in this way our condition will always satisfy. This condition always satisfy. You can think a little bit more, then you will know why this condition satisfy, because there is no element which will abide the rule which is given in the problem statement. So the tricky part is, if the value of n is 8 and number of different elements is 3, so what we have to do, we have to replace each element with two times, which will give our number of elements in our final array 6, but we have to replace two more elements. So we can take the last two elements, which last two unique elements which are present in our final array, and replace them. We can make their frequency one more, so their frequency will be 3, which are last two elements, two unique elements, and others elements frequency will be 2. So that's about the problem here. So this is the simple solution that I did. I started from last. I started not I didn't start from last. I start in this problem from starting, and take I make a sliding window of n1 is the size of set, like n1 is the number of unique elements which are present in our final array, and so I make a, what I was saying, I was making a sliding window of n1 size, n1, n1, n1 until end, and I will replace each element which are coming first. Let's say this is my n1, and the value of n1 is 3, and from 1 to 3 the number of unique elements are 2. Let's say 1 and 2 are unique elements. Here again 1 comes. So what I have to do, and the number of elements in this problem, let's say, is 1 2 3. These three are unique elements which are present in this final array. So what can I do? I can replace here 1, here 2, and here I can put 3. And in this way, if I count the value of a of I from 1 to this in our array will be 1, and the count of all these other elements will also be 1. And similarly I did it in up to last. So let's see the solution. I was not able to solve it within the contest. I retreat after that. When I went to submit this problem, then I see the contest is over. Anyways, my bad luck. So I inserted every element in my set and make the size. This is my sliding window size, and I put it in my frequency. Frequency is the number of unique elements which are present in our array. So what I did, I make a first move here. It is also not required, I think. I can start from I equal to 0. Uh, Please ignore that. I was not, because I was in hurry up because contest was finished, so I was not thinking the optimal solution. So let's say this is I starting from 0 and I less than and I plus equal to frequency. It is the sliding window. I is increasing by frequency of. So first I make my S1 clear, temp clear, and when the CNT is less than equal to frequency and J is less than this, I am inserting each unique elements in my temp, and I our B is the final array. I inserted all elements which are come first in the sliding window, which are coming in our array A. I am inserting them in my B, and then in that sliding window, the number of if the number of elements left that have not come, then I am inserting them here. And if the value of I is when to greater than n, and let's say I was saying here the value of n is 8 and 6, so we can make insert at most 6 elements and 2 elements will remain. So for that purpose I was doing it. I was making my s1 clear, temp clear, and for the last 2 elements I was inserting using the same logic as that I was using here. So it will be my final array, so which I have printed here. So this is the solution of this problem. If you have any doubt, then please feel free to ask in the comment section. And if you like the problem, then please hit the button and share it with your friends so they can also see the solution of these problems. Later on, I will also try to make editorials of other contests. So thank you guys, it's all from my side. If you have any doubt, then please feel free to ask in the comment section. So thank you guys, bye bye, take care.